The switch statement, it's an alternate to nested if. But switch statement is not easier. It may require some thinking and figuring out, but it is convenient in certain cases, and that's why I'm teaching it. But it is actually alternate to nested if. So everything you can do with switch statement can be done with nested if statements. But the switch becomes more convenient than nested if in certain cases. And we'll after we learn some examples, you will see that. I already explained that. So let's see the switch statement itself. You have to write an expression. So switch is going to be switching to different places in your program based on the value of an expression. That's what switch means. So you need to have an expression in parentheses next to the word switch. Switch expression. That expression should evaluate to be a number or a character. It cannot be anything else. Cannot be floating point number. It has to be integer. So this expression should evaluate to be integer or character. Now characters are equivalent to integers, so they can be characters. And the expression would evaluate to be a number, and case constant 1 means if the number is equal to this number, you're writing a constant number here, actual integer number or character. If the expression matches this value, then go here. That's what it means. If the expression matches this value, then go here. So it'll branch out to one of those, but it won't just do those statements. It's going to do these statements and everything below, all the other cases. So you're branching out to a certain case and telling the system to do everything below that case. That's what it's doing. And then default means if it doesn't matches any of those numbers, then do this. That's what it means. So as you can see, it's a bunch of nested if statements, basically equivalent to nested if. If expression matches constant 3, for example, it'll come to this statement and it'll do these statements and these statements and the default statements. Everything will be done. So if you don't want that, you have to tell the system not to do that. There are ways to do that. Tell the system, to not to proceed to the other constants, the other cases. So we'll go over all that as we proceed to do examples. One thing you need to remember is the expression you write here, which is called index, by the way, index of the switch, has to evaluate to be either number or character. And that number will have to match one of these. If it doesn't match one of these constants, then only the default statements will be done. Okay, moving on to example. I already explained these. Before the example, let's make sure we understand the rules. The index must evaluate to an integer or character. The default part, by the way, is not required. You only write that if you want to have it. The cases, you can have as many cases as you need. Default is just an option. Each section, after each constant, you can write many statements separated by semicolons, and you don't need brackets for that. It'll recognize all those statements to be part of that constant, part of that one case. So no need for brackets when you write multiple statements. Okay, so let's go to simple example. We're going to write a little program that will determine whether a given number is a multiple of 5 or not, and write the conclusion. So the number, if the number is a multiple of 5, then it will be divisible by 5. So we are going to switch based on n modulus 5. Our index is n modulus 5. So if this number is divisible by 5, if the m is divisible by 5, then this m modulus 5 will be 0. According to the problem, you had to get the number from user. So we get the number from user, read into M, and then if M modulus, basically this says if M modulus 5 is 0, then go to the case 0. Otherwise, go to whatever the value is. So M modulus 5 is the remainder of dividing by 5. So it would be, uh, if it is not 0, then it could be 1, 2, 3, or 4. Remember, the remainder will be less than 5. So it can be any one of those numbers, 1, 2, 3, 4. So that's why I'm saying K0. That means if M modulus 5 is 0, then see out number is multiple of 5, ENDL. And case 1, I have case 1 blank. For a reason. If it comes to case 1, or case 2, or case 3, or case 4, I only have one conclusion in all those cases. Like this, number is not multiple of 5. So that's why I left them blank. I don't need to repeat this statement because I know that if it goes to case 1, it's going to do everything below that. So it's going to end up doing this. And therefore, the outcome will be, if the case is, if the M modulus 5 is 1, 2, 3, or 4, the outcome will be this. This will be printed. Only if the value of M modulus 5 is 0, then this will be printed. Now we have a small error here. This is not perfectly right. Anybody can recognize the error?
You need a break.
Yes. Why? Where? Uh,
Right, right on case 0, right?
yes, right
And
after case 0. If you don't get out of that structure after putting this message, the way it is, if you just run this program, if M modulus 5 is actually divisible, then it'll be 0, right? The remainder is 0. When the remainder is 0, it's going to write this conclusion and this conclusion, two conclusions, two opposite conclusions, which is not right. Everybody see why, right? Okay, one student noticed it. The way it is not right because if it goes to case 0, it's going to do everything below that. So therefore, it's going to end up doing this. So you have to tell the system not to do that. And that's what the break statement is for. I need to write a break statement right after this. A break statement will break out of any structure. No matter where it is, it'll just get out of that entire structure. That's what break means. So a break statement right after this line will make the system move out of the switch without writing this. Otherwise, you will end up writing both opposite conclusions. Now, let me, at this point, I'm introducing break statement here, but um, even though break statement can be used to break out of any structure, um, getting out of any other structure using break is considered to be bad programming. It's considered to be very sloppy programming. It'll confuse any reader. Um, it will be very hard to understand the program. And therefore, as a standard rule for programmers, break should not be used anywhere except switch. Switch is the only place you're allowed to use break statement. I'm sure some of you later after we learn loop, I have had students writing break in the loop. That would be penalized badly because breaking out of loop is sloppy programming and it'll be hard for anybody to understand. And you yourself will get lost with that kind of approach.
So
So
do you break after every case?
if you have statements in every case, then you have to put break after it if you don't want the other statements to be executed. Yes. So yes, very often in switch statement, you need a break statement after every case.
What about do you need to could you go back? Yeah. So what if you want case 4
Yeah.
but you put a break after case 0, it's going to just jump to case 4 and then do that, right? And it's going to skip over case 0.
If you put a break after the case 4,
No,
then,
I'm saying if there's a break after case 0, right? But M is not a multiple of 5.
okay.
Right.
Let
What
me
if-
let me put that break. You're saying break right here, right?
Yeah.
Okay, so remember, you don't need brackets. You can just write any number of statements. So I'm writing a break right there. That's what you need to make this work. All right, with that, what is your question?
So if M is not a multiple of 5, it will skip over 0 and skip over the break and just jump to case 1, 2, 3, and 4. Correct?
Exactly. So if M modulus 5 is not 0, it's going to be 1, 2, 3, or 4. So it's going to switch to one of these cases. If it goes to one of these cases, it'll go to all the other cases below it and end up doing this as output. Okay.
Okay. And I have to type out case 1, 2, 3, and 4.
Yes, because M modulus 5, if it is not 0, it can be 1. If you don't write case 1, then the program is going to fail. It's not going to write the right answer, right?
Okay.
If you don't have this case 1 here, if that's missing, suppose that M modulus 5 is 1, then what happens? None of these will be nothing will be written on the screen. It'll move out of the switch and go on to the next statement.
Could you do case 0 and default instead of case 1, 2, 3?
Yes, good question. That's an excellent question. Yes, instead of writing 1, 2, 3, 4, I could have written default in place of all this. That is absolutely right. This would have done the same thing. You need a colon there. Yeah, this would have done the same thing, exactly. So there are alternate ways to use this idea, use this statement. So this will be correct. I wrote the case 1, 2, 3, 4 just to show you that you can do it that way too. Kelvin A. Okay. Any other question? All right, that's excellent. That's excellent discussion. Let's move on.
Does it have to be case 0 and then ... Are you supposed to space it out like another line?
For each case, you mean?
Yeah.
After each case number, the case 0, like this, you need a colon,
Mm.
and then you don't need a space. This can go right next to it.
Okay.
And then break statement, technically the break statement could be written up here. If you write here, it's not wrong. Compiler will take it, but we don't recommend that, right? We like you to write every statement on new line. But the semicolons are separating them. So therefore system knows that they are separate statements. Yeah, that's all there is. No need for spaces, but the colons are necessary. Between case and the number, yes, you need a space, obviously. Okay, so moving on. The break terminates out of any construct, any structure. And programmers sometimes use that, in other structures, and that's prohibited. I had to warn you now that breaking out of loop is completely prohibited, and you may not get any credit for that program if you do that. That's coming up. Loop is coming up next, and that's a structure. It needs the loop structure is sometimes difficult to figure out, and so they take this easy way out of using break, and that's not right practice. So well, when we discuss loop, I'll give you that warning again. Moving on to the next example. Yeah, this is the right way to write that last program. I already wrote that for you. moving on to the next. The writing the letter grades A, B, C, D, E. That's my next example. I thought I have another example. 1 second. I may have skipped something here. All right, I think that's coming up later. One more example using characters. It's coming up later. But I want to explain this programming task, writing letter grade based on the grade range. So as I explained before, in a switch statement, you can only have a expression that evaluates to be a number or a character, integer number or character. You cannot use a range in switch, but in an if statement, we can use a range. So if you recall the program we wrote to write the letter grade, we said if grade is less, we started at 90. If the grade is over 90, write A, else, that means it's under 90 now. Then if it is over 80, then write B. So we were doing ranges. If the grade is between 80 and 90, then it's B and all that. You cannot do that in the switch. You can only have an expression that evaluates to be an integer. So if I want to write letter grades based on the number grades that the students have, can I use switch statement? Yes, it's a little bit tricky to use switch statement, but if you work out the expression correctly, it is an elegant programming idea. So I'm going to show you how to come up with an expression. You have to come up with an expression that translates to a number which covers the intervals of less than 60 or 60 to 70, 70 to 80. Those intervals have to come down to corresponding to some integer numbers. So you basically have to come up with an expression that will do that, that will translate those intervals into numbers. So I'm going to show you one of those. I'm going to use one of those expression to explain, but often there is more than one. So fortunately, you can sometimes come up with your own expression that will work. That's not necessarily same as mine. But I'm going to explain one of my own expressions. If I take this expression grade, whatever the grade is, I have to get the grade from the instructor. We are writing this program to help an instructor write letter grades for his students. So the grade has to come from the instructor. And after that, my expression is going to be this. I'm going to take away 50 from grade, whatever grade is. If I subtract 50 and divide by 2, that will translate to an integer. Divide by 10 and then take integer part of it and assign it to an integer variable called index, index. I'm not writing program right now. I'm writing algebraic expression here to show you what expression I'm going to use. So if I use this expression, I'm going to explain why this works, but like I said, there are other expressions you can use that can still work. If the grade is over 60, you can see that if the grade is over 60, so like 65, for example, then 65 minus 50 is 15. If you divide by 10, it's 1.5. If the grade is 61, it's 1.1. Can you see that is 61 minus 50 equal to 11. And when you divide by 10, it's equal to 1.1. And when I take integer part, I'm getting 1. So what I'm trying to say is if the grade is over 60, no matter over 60, but under 70, this will give you 1. The integer part of this will be 1. If the grade is over 70, like 73 minus 50 over 10 is 23 over 10, which is 2.3. The integer part is 2. So this gives you 2. So when the grade is above 70, you're getting 2. When the grade is above 80, you're going to get 3. Let me explain that also. 83 minus 50 over 10 will be 33 over 10, which is 3.3. Integer part is 3. So I'm basically translating my intervals into integers. If the number is above 60 but under 70, I'll get a 1 from this. If it is above 70, under 80, it'll be 2. If it is above 80, the number will be 3, and so on. So therefore, I'm going to use this index and write the program. You can begin the program and then ask the user to enter the grade. Well, I need a floating type variable grade. And then I need index. I'm going to declare integer type index. And then as I'll get the grade from the user, I'm going to show you the whole program. It's written on the slide, but I want to take you step by step. So ask for the grade and see in grade. As soon as you get the grade, you compute this expression, index, equal to grade minus 50 divided by 10. This is just one expression I came up with, but I will show you in a minute. If you choose a different expression, you can make it work. So this will be an integer, and that integer is what I'm going to use to switch. Switch index, and then you write, you had to have a curly bracket and then case. Case 1. So like I said, if it is about 60, it'll be 1. And then about 70 will be 2. So you can begin with the case 1. See out. A, pass or D, whatever you want to write as grade. And then case 2 and so on. So that's starting with the case 1. You can start with the case 4. Well, case 80 and above will be 3, 90 and above will be 4. But when it is 90 and above, you have to consider 100 also. 100 is a possible grade, right? So when it is 100, it's 5. 100 minus 50 is 50, over 10 is 5. So there are 2 cases for the grade A, 5 and 4. We had to incorporate all that. You have to make sure you cover all the different cases. So I'm going to go to the program, and this is just the way I decide to write, but there are different expressions that can work. Grade minus 50 over 10, that's my index. And the index is 504, then the grade is A, and then break. If it is 3, grade is B, break. If it is 2, grade is C, break. If it is 1, it's D, break. Default, that's because if it is under 60, it could be any number. Could be over 40, over 30, over 10, there are different possibilities. They're all corresponding to fail. So therefore, I can just put them all under default. So if it doesn't match is the 5, 4, 3, 2, 1 cases, then we know it's failing grade. So you can just put all of the other ones under the default. But you have to make sure you cover all the possible cases. Don't leave out anything. And this does. Now, let me explain why there is the expression that you use is not unique. You can actually come up with a different expression that'll work. So what if I want to use, in this case, can I use just grade over 10? Is that something? I'll show you what you can use. Instead of subtracting 50, if I choose index to be grade over 10, and then take integer part. So index has been declared as int, so you're taking integer part. So if you do that, then the grade, if the grade is 90 or above, then this will be a 9. Or 10, right? 9 or 10. So you can use, you can say that if this is equal to 9 or 10, then the grade is A. But then what are the other possibilities? If it is 80 or better, then it'll be 8. This will be 8. So I can say switch index case, in the bracket, case 10 colon. You don't need to write anything there because if it is 9 or 10, it'll be A. So I'm writing both cases and then writing C out A. That way, if it comes to 10 or 9, it'll write this grade A. And then case 8, you can see that the if it is over 80, it'll be 8. So you can see out B in that case. And then case 7. So only the case numbers are different now. In the other method, my case numbers were 5, 4, 3, 2, 1. Now it's 9, 10, 9, 8, 7, 6, and then default. So as you can see, it can be worked out even with this expression, grade over 10. So it's the expression is not unique, and so you can come up with your own. But here, I don't see any other expression that can work. So depending on the problem, you may be able to come up with different expressions. So I don't expect your expression to match another student's expression for the problems you're going to be doing. It doesn't have to be. All right, so let's go to, yeah, this is my example with the characters. I was wondering what happened. All right, so I'm going to write a program that'll get a character data from the user and determine whether it's a punctuation character or not and write the conclusion. So I can use switch statement. You used, I think I gave you an exercise to use if statement for this. If I believe there was one in an earlier homework. But we are writing that same thing with the switch statement now. All right, so character data variable is declared and ask for the character, read it into val, and then switch based on val. You know, remember the expression can be character or number, integer number or character. So the val is a character now. So case val, that's period. You have to put those in quotes whenever you're using character data, or comma, or if it is colon or semicolon, all of those are punctuation characters. And the list is longer than this. I just made it shorter. So in any of these cases, we want to write this conclusion and break. If it is not one of those, then default will be executed. So no punctuation character. So if the val is equal to one of those punctuation characters, it will write the conclusion punctuation character. If it doesn't match, it'll go to the default case and it'll write no punctuation character. So that's, yeah, let's do this warm-up exercise. It says a department store is about to have a sale and the prices are going to be reduced by a certain percentage, and the percentage depends on the range of the current price. So as you can see, we have a range here for each number. So I decided to give you this exercise now to see if you can come up with the expression that will translate this range to integers. All right. So if you come up with that expression, then the rest is straightforward. So go ahead, figure out the expression. You can write your answer in the chat or show it to me on the camera. I wrote the statements that we have to write before we get to the index. All right, I don't see anything in the chat. If you can just give me the expression, I can tell you whether it's right or not. Like I said, more than one expression can be right.
There's a problem in the question, I think.
Okay.
Don't the price ranges overlap? So if you're at 30, you're both 10% and 12%?
Yeah, usually always it means the right endpoint is not included. So 0 to 30 means 0 to under 30.
Okay, thank you.
All right. Mhm. Okay, I see the chat. So let's check that. Okay, Alexander's expression is right. It can be worked out with that. And so, yes, it's right. There are other expressions that can work. I can already see two expressions that can work. I don't see anything else. And if there is somebody coming up with another creative one, I like to see that. But Alexander, yours is right. So you can continue to write the rest of it with that expression.
Thank you. I'm working it out right now.
Okay. No one else has another expression? Still, no, price, one student says price minus 30. Just price minus 30, I don't see how to make that work. No, I have to say it cannot work. When you take remember the number has to be integer. The expression has to produce integer. And so if the integer is too big or if you have to use too large number of integers to represent one conclusion, that'll be not good. All right. No one has another expression. If nothing more, then I'll have to go ahead and explain it to you one way. All right, let me explain. You can see that the range, the interval range is 30, right? The numbers are 0 to 30 and the 30 to 60. The size of the range is 30. The width of the range is 30. So that's when it makes sense to subtract 30, then divide by 10. That's what I'm going to do here. So price minus 30 divided by 10. That's what I'm going to try. This, if the number is above 90, let's go to the above 90 case. If it is about 90, 90 minus 30 is 60, divided by 10 will be 6. That will be 6, and then 60 to 90 will be a different number. So therefore 6 and above. So we can include that in default. If it is 90 and above, so you have to worry about that. 90 and above means it could be 100, 110, 120, huge range above that. So I'm going to work with this 0 to 30 as my beginning. So switch. If it is the index, and if the number is in the range 0 to 30, then subtracting 30 and dividing by 10 will produce a 0. See, if it is under 30, then it's more like 25. 25 minus 30 is a negative number. Sorry, it's a negative number. Divided by 10 will be negative. So anything under 30 is going to produce negative number. So the negative number can be different. 10, actually, it's going to be negative, but it is 0. So therefore, I can just put that case as 0, because whether it's 0, it is negative, it's still 0. So therefore, I can say switch case 0. The percentage will be 10. So I'm going to use my variable name percent to keep track of the percentage. Percent equal to 0.10. And case, if it is about 30 but under 60, then subtracting 30 and dividing by 10 will produce a 1. You can see that, right? If it is 35, 35 minus 30 over 10. No, it's going to be 35 minus 30 is 5 over 10. That's 0.5. That's 0. It's going to be, that's also going into 0. Okay, so my expression is not working out. Yeah, in two cases, I'm getting 0. 30 to 60 is also 0. So it's 20, price minus 20. Yeah, it looks like subtracting 30 is not going to work out. So I'm going to change it to price divided by 10, simply dividing price by 10. Then if it is in the range 0 to 30, then it's under 30. So dividing by 10 and taking integer will produce 2 or 1. So there are two cases, case 2 and case 1. Both cases will be will give you 10%. So percent equal to 10 in both cases. I'm only keeping track of the percentage, and at the end, I'll subtract that percentage to get the new price. So if it is in the range 30 to 60, then dividing by 10 will produce either 4 or 5, right? It's either, if it is about 30, no, 3, 4, 5, 3 numbers are there. So 3 numbers will be okay. I can put a break statement here, and then case 3 colon case 4. Sorry about my pencil, it's not working properly today. Case 4, case 5. All these cases will be the numbers, the integer in the range 30 to 60. In that case, my percent is equal to 12% or 0.12 and break. So I have 3 different numbers for each interval. That's okay. But if you have to have 5 different numbers for an interval, that's a little bit too much. So dividing by 10 creates 3 different numbers for each interval. Subtracting 30 didn't work out, but subtracting 20 and dividing by 10 might work out. I didn't check that out. So there are, as you can see, subtracting 30 didn't work out in this case. If it produces same number for 2 different intervals, then that's not going to work. It has to be a different number for each interval. And so price divided by 10, as you can see, works out, but you have 3 numbers for each cases. So that can happen, that's allowed. But the list of numbers that correspond to each interval should not be too many. Then the program will be extremely long. Then the idea of using switch is not good in that case. So it's not recommended for such problems. All right, so that basically finishes our section 3.5. And so I'm going to move on to the next topic. So let me clear the board.
Can we make one more on this topic?
I'm sorry?
Would you show us one more example on a switch? So maybe something simple.
Well, something simple. I thought I have shown you enough of those. I can't think of one right now. If you ask a question, I can try to answer, but I don't have one prepared right now. Okay. I mean, very common examples are like these intervals, and based on the width of those intervals, you can figure out an expression. But maybe that's the kind of problem you're trying to get an example of. Is that what you want? Problems with intervals?
Yes, please.
Yeah, I have shown you 2 of them. So, for example, if it is, if the problem says 0 to 20, if the range is under 20, let me get a pencil. All right, if the price is under 20, then you need to reduce by 5%. Price is between 20 and 30, then 7%. I'm just making up an example. If it is 30 to 40, then it's 10%. All right. Suppose that you're supposed to reduce by these percentages. Okay, so what expression could work for the price? Let's say price, you get the price from the user. CN price. And then if this is the range, can anybody tell me what would be a good expression? The width of the range is 10. So when the width is 10, either subtracting 10 and dividing by 10, or actually so just dividing by 10 will work better in this case, as I see. If I divide by 10, then if the number is in the range 20, under 20, then it'll be 0, right? If it is under 20, like 18 over 10 is 1. No, it's 1. It's going to be 1. 1.8 and integer part is 1. So if it is under 20, it's going to be 1 or 0. Well, if it is about 10, like 18, then it's 1. If it is below 10, you're going to get 0. So 0 and 1 are the two cases. So switch index case 0 and case 1 would correspond to percentage 5 or 5. And then you can see if it is in the range 20 to 30, then it's going to be 2, right? Like 25 over 10 is 2.5, integer part is 2, and that's going to happen for any number in that range. So case is 2 for that. And if it is 30 to 40, the case 3 covers that, right? You can see that. So just dividing by 10 works. And then for all prices above 40, they say above 40, they have another number, 15%. Then you can put that in default. All above means that when it says above certain number, that's a huge range. It's, above 40 means 50, 60, 70, all those are covered. So it's best to put it on the default. Default will be the next number, whatever that, 15%, okay. Default percent is 15. Okay, the writing is coming out horrible today. The pencil is poorly functioning. But you got the picture, right? So just dividing by 10 works, but you had to work out the range. 0 and 1 covers the first interval under 20, and about 40 is put under default to cover all other possibilities. All right, so I'm going to move on to section 4.1 and do as much as we can. Loops. Loop is a very important technique in programming, and it basically is necessary in advanced programming, everywhere, and that's why before going into more advanced topics, we need to understand loops. The loop basically makes the system do something repeatedly over and over. So whenever you need to say do this over and over, you need loop. And so right now you don't know exactly when we have to do something over and over. So I'm going to begin with I will begin with a simple example that tells you why we sometimes need to repeat. So let's first understand what loop structures are there. There's while loop, and then do while loop, and then for loop, 3 kinds of loop. The do while loop I'm going to be skipping because it's essentially same as while loops. There's a small difference. For loop is important because it's convenient in certain situations. So those are different structures, but the idea of loop is the same, repetition. That's what we're doing. So let's understand the while loop first. While loop is it's basically going to say to the system, while something is true, repeat. So there's a condition that goes with the loop statement. And so here's how the statement goes. While, and then parentheses, expression. That means while this expression is true, repeat the statement. So when the while statement says repeat, that hidden word is there. While expression is true, repeat the statement. And this structure on the other side is while expression is true, repeat all of these statements. So you need curly brackets if you want to repeat all of them, many statements. Other than that, it's very simple. And as you can see, I indented the statements that will be repeated, just like if statement. In the while statement also, you have to indent everything that is inside the loop. What is inside the loop means the expressions that would be, or the statements that will be repeated, that will be executed over and over. So the expression here will be a logical expression, a condition basically, such as val less than or equal to 5. So if I say while val is less than or equal to 5, repeat the following, that means only when the val less than or equal to 5 is false, it'll stop. As long as val less than or equal to 5 is true, it'll keep going. So this condition will be checked over and over every time. And the condition, if it remains true, it'll repeat. So you have to make sure the condition will become false at some point. If you don't, then you have infinite loop. Infinite loop means the system is going to be stuck with that statement forever, and you won't see any result on the screen. So when the system is stuck with a statement, the only way to get out of that is to shut down the computer, or Control Alt Delete in your Windows system. One of those is the only way to get out. So that's not good programming. You should avoid getting into infinite loops. So you have to make sure the condition of the loop will become false at some point. Usually it's not very difficult to figure out when you want the condition to become false, when your job is done. So you have to decide when the job is done. And at that point, when the job is done, the condition should be false. And so I'm going to begin with an explanation of exactly how it will behave. And then I'm going to, after we see the first example, you'll understand better. So if you write this, while expression and then statements, the way it works is, it'll begin by evaluating the expression. So at the beginning, this expression must be true. Otherwise, the loop will never get started. So expression will be evaluated first. If it is true, then it will do these statements inside. And then when it finishes that, when it hits this bracket, it'll go back to the top and it'll evaluate the expression again. And if the expression is true, it'll do this statement and this statement, all of the statements inside. And when it hits this bracket, it'll go back up and evaluate the expression again. So one of these statements that you write in here should be changing the value of the expression to make it false at some point. Only then the loop is right. If it doesn't become false, you're stuck in an infinite loop. Infinite loop is not going to give you credit. It's wrong. So you have to make sure you write the statements inside the loop correctly so that the condition will become false. So that's how it's going to work. And so we will see when we need a loop by simply looking at this example. Suppose that we need an integer, we need to have the system write all the integers between 1 and 100, all the integers from 1 to 100. Okay, so very simple task. I want the computer to write the numbers 1 through 100 on the screen, one below the other. Okay, so think about how you would do it. with the method we only know, the only thing we can say is cout1 endl, cout2 endl, and keep writing these. How many statements? 100 statements. We'll be working harder than the computer, much harder than the computer to get this done. So we shouldn't be writing 100 statements. Instead, is there any other way we can tell the system to write all the numbers 1 through 100 on the screen? How about this? I set the variable n to 1. I store 1 in a variable called n. And then I say cout n, that'll be 1. N has a 1 right now. endl, go to the next line. And then my next statement in the program is n equal to n plus 1. So that increases n to 2. After increasing n to 2, if I make it go back to this cout statement, then now I'm writing 2 and going to next line. And if I can repeat these two statements, then I'm saying after couting 2, execute this one. So now n is changing to 3, and then I'm writing 3. N is changing to 4, I'm writing 4. So I need to, that's exactly what we need. We need to say, repeat these two. Repeat these two statements while what is true? Anybody?
Less than or equal to 100.
While n is less than or equal to 100, exactly. So that means to get that job done, I can write a while loop in the following way. So I can say while n less than or equal to 100. Now, when you write this condition n less than or equal to 100, you need to make sure n has a value to begin with, and this condition will be true at the beginning. So that means I need to do int n equal to 1 at first. And so with that 1, this condition is true, so the loop will get started. And inside, I need to say cout n endl, and then what's next? I need to change the n equal to n plus 1. So I need two statements in the loop. Both of these have to be repeated. That's when you need bracket. If you don't put bracket, you're only repeating cout n, only one statement. So with the bracket, I'm repeating both of these statements. So let's see how it works. N is 1, and this condition is true. You have to make sure a condition is true initially, and it'll write the 1 on the screen. So on the screen, I'll have 1 now, and then n changes to 2. The memory cell n was 1, now it changes to 2. And then with the 2, it goes up, and the condition is still true, so it'll write the n. So now you have 2. endl will go to next line, and n changes to 3. And with that, you go back up. This is true, so cout n will work, and 3 is written. And then n changes to 4, and it keeps going. Eventually, when n is 100, you have to check the last step also to make sure. So when n is equal to 100, what's happening? N less than or equal to 100 is true, so cout n will still work. So you're writing the 100, and then n becomes 101 right here. N becomes 101, and you go here. This is not true anymore. The condition is not true anymore. Loop terminates. N does become 101, but it doesn't print 101. You need to make sure the last number printed is the number you wanted to print. So 100 is printed, 101 is not printed, loop terminates with 101. And when the loop terminates, it'll go to the next statement in the program, whatever that is. That's how it works. So this program I have written here will write the numbers 1 through 100 on the screen. And so that's all, that's what we needed. Okay, so let's understand. Yeah, I'm going to, yeah, it's that same program written here.
Actually, Professor, we're over time.
Oh, right, okay. I just realized.
To go to
Okay,
class.
all right, so we'll stop here, and I may have one or two question on loops, but I will put the numbers, the problem numbers on the link, the problems you have to turn in. All right, we'll continue with the loops in the next class.
Is it possible if you could show me really quick?
Yeah.
A rounding.
Okay, yeah, this is Jonathan, right?
Yeah.
All right, I'll explain that, Jonathan, in a second. So others, if you have class, you can leave. Have a nice day. I'll see you Wednesday. But I can explain to Jonathan whatever he has. Yeah, well, go ahead. Rounding what again?
Rounding to the nearest hundredth. Because I know it's plus 0.5
Uh-huh.
round to the integer, but
Yeah,
then rounding to the nearest hundred is different.
yeah, you need to multiply 100 to move decimal point over by 2 places. Okay, like this number. If we have 5.673, first you had to move the decimal point over behind this. Okay, to do that, you had to multiply by 100. Then add 0.5. So now it's 567.3. And if you add 0.5, then depending on this last digit, the 7 will change. Here, it's not going to change, right? So the process is multiply by 100 first, and then add 0.5, then take integer part and divide by 100 to bring the decimal point back. Those are the steps. So let me show you with all right, I had to clear the board to explain that. Okay, if it is 3.677 or 3.673, you're rounding at this digit right here. So that means if the next digit is over 7, this digit should go up. That we can make that happen by first multiplying by 100. That'll make it 367.7. In this case, when you multiply by 100, it'll make it 367.3. And then you add 0.5, that'll make it 368.2 in this case, and it'll make it 367.8. See, this digit didn't change here. And after that, you take integer part, that'll give you 368 in this case, and 367 in this case. And now divide by 100 to move the decimal point back to where it was. But you had to divide by 100 points. Otherwise, you'll get only integer part. So 36.8 in this case, and 36.7 in this case. So as you can see, we round it at the 100th digit. Okay.
Okay.
Multiply by 100, add 0.5, take integer part, divide by 100 point.
So on a program that would look like n
Plus n
N?
times 100
times 100
plus 0.5,
plus 0.5
and then quantity int outside in front of the quantity.
int and then variable. So int n times 100 plus 0.5.
No. Just whatever original number was, add 100. Okay.
But you're supposed to put it into a variable because, like, let's say they put in their own number and it becomes a float, and then that float is
All right, let's say the float x has the value. Okay, float x has the value. Then you take x plus 0.5. You don't take integer part of x. You just take original x plus 0.5. Okay. And oops, sorry, not 0.9. Original x multiply by 100, and then add 0.5, right? Only after that you need to take integer part. Okay.
Oh, so you have to put it out of the bracket?
Yeah.
Parentheses?
Int has to be in front of the entire expression.
Okay, and
Then divide by 100 point.
divided by 100. And that's
That's now rounded. Yeah.
okay.
So put it back in X if you need.
Okay.
Alright.
So I was emailing you, but I couldn't send out the it wouldn't let me send the picture for an attachment.
Okay.
But it was for LLDB on Xcode. It's like an error message. So I just started using a different platform.
I'm not following you. So what's the problem? You have a problem with the assignment?
No, it's whenever I'm using Xcode, I'm getting a an error message,
With this expression?
but it's not. It's a green error message. I've never seen that before. It's called.
All right, Jonathan, I don't have time to discuss that right now. I have the other class in 1 minute.
Okay.
All right, sorry about that. You can bring it up in the office hours if you want to discuss that.
Okay.
All right. Okay.
Thanks.
Bye now.
Have a nice day, sir. Bye.
Have a nice day.
Yeah, you too. Have a nice day.
Have a good day.
You too. Bye.